Hi everyone, today we will talk about reflection of light. You must have noticed that when you look the image of an object in a plane mirror, you find that the right seems to go to the left and the left goes to the right. So there is a very famous question among students and among people that why do mirrors reverse right to left and left to right? Why not up to down and down to up? So to answer this question, we will first learn about how reflection takes place and what is the physics behind reflection. So in this diagram, I am representing the line PQ as a plane mirror, and you can consider this point A as a source of light. Think of it as a small bulb. The light from this bulb, it obviously goes in all directions, but let us consider two such rays of light. One of the ray, it hits the mirror perpendicularly, so therefore it just goes back in the same line. This is similar to throwing a ball perpendicular on a surface. It will just go back in the same line, right? Now, if you consider this ray which comes at some angle to this normal to the mirror, then the light will reflect in this direction. This is similar to throwing the ball on a surface at some angle. It goes back in this direction, right? Okay. This angle, if this is 30 degree, let's assume, then this is also 30 degree. And this is what we call the law of reflection in physics. Now look at the reflected rays. This is one reflected ray and this is one reflected ray. Where do they meet? Well, they will not meet this side. However, when you observe the reflected rays, meaning when you see from here, you will see the reflected rays appear to come from this point. And that point, wherever the reflected rays meet or they appear to meet, that is what we call the image of this object. So when you see from here, you will see the image of this object is formed here. Now look at something very interesting. If this is 30 degree, then this is also 30 degree from alternate angles. And if this is 30 degree, this is also 30 degree from corresponding angles. So if this angle and this angle are same, this is 90, this is also 90, and this side is common for both the triangles, this and this. Therefore, this triangle and this triangle are congruent triangles. Therefore, this distance, if I say is x, and this distance, if I say is y, then x must be equal to y. That means what? That means if you are 1 meter in front of the mirror, your image is exactly 1 meter behind the mirror. Keep this fact in your mind. So what we just learned is if there is an object 1 meter in front of the mirror, image would be 1 meter behind the mirror. Having understood that, let us concentrate on this diagram. I have drawn this to give you a 3-dimensional feeling. So this is a room you can imagine, and this is a plane mirror. The surface with the red color represents a plane mirror. Now imagine I keep an object this way on this wall, AB. Then from whatever we have learned, the image of A will be formed same distance behind. Let us call it A dash. And the image of B will be formed same distance behind, B dash. And therefore your image of AB will appear like this. So if you look carefully, if you call this the left, then this is still the left, right? And if this is the right, this is still the right. For somebody observing this from here, if this is the left, this is the right, and therefore on the image, this is still the left and this is still the right. So you see, reflection did not change right into left or left into right. Similarly, instead of keeping the object this way, if you keep the object this way, observe how your image will be formed. So this point A will be formed, the image will be formed same distance behind, A dash, and image of this will be formed same distance behind. So the image will be like this. So you can see even here that the up remains up and the down remains down. So what we have learned is plane mirrors do not reflect right to left and left to right. neither they reflect up to down and down to up. And what they do? Well, what they do is, instead of keeping the object parallel to the mirror, like I did in the first case and the second case, let me keep it perpendicular to the mirror, such that this point B is on the wall and this point A is in front of the mirror. I hope you understood. This is the mirror. I am keeping the object this way. Then from whatever we learned, we know the image of this A will be same distance behind the mirror. So since A is nearer to the mirror, image also should be nearer to the mirror, A dash. And the image of B is on the wall, so image of B should be also on the wall on the other side. So this is what a mirror does. So the mirror, if the object is kept this way, the image will be formed this way, right? Okay. To explain all these things in an experimental way, I have done a lot of demonstrations yesterday. So I'd like to show all of them to you. Please go through it.
Please observe this. As you can see, L is on the left, R is on the right, U is up and D is down. Now, without changing its orientation, if I bring it towards a mirror and see the image, observe that L is still on the left, R is on the right, U is up, D is down. So there is no change. However, when people observe the image of this on the mirror, they will flip it this way, right? Now look at the process of my flipping. As I flip, the R is going to the left and left is coming to the right. And that's why the image simply shows whatever you have done. It's not the property of reflection to change left into right, but it's your process of flipping it horizontally that makes the image as you observe. The L is now on my right and R is on the left. Instead of flipping horizontally, which most of the people do, if I flip it vertically, something like this, and observe its image, you can see now the R and L are still on my right and left, so no change there. But the D is now up and U is now down. So if people had flipped vertically instead of horizontally, they would have complained that okay, due to reflection, the up becomes down and the down becomes up. Notice that the image of this object as seen on the mirror is same as how the object would appear if I see from behind. So the way the object appears from behind is same as the image that you see. So next time when you see yourself in the mirror, don't think the watch which you are wearing on the right hand is in the mirror on the left hand. No, it is not on the left hand, it is on the right hand. Observe carefully, this is your right hand side, okay? However, what you see in the mirror is what you would have seen if you would go back and observe this part from behind. That is how the mirror reflection works. Now since nobody can actually go behind and from back see your front, obviously nobody has seen you the way you look yourself in the mirror. However, if you want to see how others look at you, what you need to do is just take a selfie with your camera. I'll give you an example. With a marker, let me make a black spot here on my left cheek. Okay, I will take a selfie with this and I'll post it in the video. Just check it out how it looks. Were you surprised that the mark is on the right hand cheek? What happened? Well, the selfie is designed so that you can see what others see when they look at your face. Now they cannot see my face from behind, so they have to turn. Now when they come and turn in front of me this way, what happens? It is similar to that flipping of that paper. Remember, the left goes to right and the right goes to left? Yes. So as they turn around and they observe me, they will see this mark on their right hand side. So remember, the mark on the left hand did not go on the right because of reflection. It is because the person has to turn around. So this turning process is what makes the left to right and the right to left. Imagine I write ambulance on a car in this way, the way we normally write. Now see how it would appear to a driver who is in front of the ambulance and the ambulance is coming from behind. You see the driver is unable to read whatever he sees on his mirror, right? So if I see this word ambulance which I have written from behind, and if I write ambulance on the car this way, then let's see what happens. I made it slightly darker so that it is visible. Now imagine this car is coming from behind. Observe you as the driver in front. What do you see? It's wonderful, right? Ambulance.